Bismillahirrahmanirrahim. Dear viewers, now we will continue our design course of 3D portal frame in Staad Pro. So I wanted to apply load here, then I wanted to copy the frame, but in Staad Pro we have to follow the sequence. We have to finish the model, then we have to apply the loads. So we will finish the modeling first. Go to view, select this one, then go to geometry, translational repeat 5.5, and it will be along x-axis. Here x-axis we will check the drawing how much. Here it is 1 2 3 4 5 number 5. Okay, then we will go to view, we will select the end frame, then we will go to geometry, copy this 38.5 meter. Okay, now our frame modeling finished. Now we will model the stud. So we will go to view, this side we will go to select node cursor, this one, control this one and this one, go to 3D view, see all the nodes selected, red colored, and I will go to geometry, here connect beam along x-axis. Okay, now I will define properties, go to property, define, I want to provide tube, square tube 0.125 and thickness 0.05 meter, that means 5 millimeter. Add. Okay, now I will go to select parallel to x-axis, then I will assign yes. I want to release the moment for this start section. I will go to specification, beam, then here start partial release mpz 0.99, add, and beam end partial release mpz 0.99, 99% moment release. So I will select this one, assign to selected beam, assign yes, and this one assign yes. Now I will model bracing. I will click on this. Now here this point to this point, here to here, then from here to here, here to here, here to here. This is middle of the rafter. We have to add the node at the middle. I have added the node at the middle of the rafter, and following that nodes to model the bracing. Okay, in this way we will model bracing for this bay and this end bay. So we have finished our bracing modeling. Now as bracing will act as a tension member, we will define it as tension member. We will go to specification, beam, add tension, we will add member tension, we will select the bracings, we will go to select, then we will go by property name, by property, then so we have to define bracing property first, so that we can select this. We will go to define, I will go to circle, I will use tension rod, so 25 millimeter rod, 0.025 meter diameter, steel, add, close. Now I will go to select property or missing property this, then I will assign to selected name. Now I can select by property name, by property this circle, then I will go to specification, member tension, assign selected beams, yes, okay. So we have finished our modeling part. Now we will go for load application. Here loading, we will go to load case details, as we are assigning calculated user defined load on frame. I'll go to add dead load DL, add, then live load LL, add wind load W ZX, add WZ minus, add WX plus, add WX minus, add, close. Now the load calculation, I have shown this load calculation in my previous design course on SAP 2000. There you can check the procedure, and I have shared the Excel link in the description of this tutorials in my channel. You can check that playlist named by design course on 3D portal frame using SAP 2000. So now same spacing and same height I have used here for Staad Pro modeling, so same load I will use here. Here dead load on the frame 0.444 and collateral load, this total dead load I will use 1.82. I will go to view. First I will assign the self weight -1, add, okay. Then dead load I will add member uniform 1.82 minus 1.82, add, and half for the end frame, it will be 0.91, yes, okay. Then I will go for live load, add this member uniform, live load is 3.14 minus 3.14, add, for end frame it will be 1.57, add. Now I will go to WZ plus, along Z direction, windward wall 3.85, we will add 3.86, along Z direction, windward wall 3.86, add, and for in frame it will be 1.93, add, okay. Then windward roof 4.4, that means upward from in the direction of local y-axis of frame, local y-axis upward direction, it will be 4.4, add, and there will be for in frame 2.2, add. Now we will go to leeward roof. For leeward roof it is 2.75, we will apply 2.76, add, and half of this 1.38, add. And now leeward wall also same. Leeward wall, that means this side along z direction, gz 2.76, add, and 1.38, add. Okay, now we'll go for side wall 4.62. this side wall is here, this direction, positive x direction and negative x direction side wall. So we'll select x and this one 4.62, add half of this 2.31, add, and minus 4.62, add, and 2.31, add. Okay, now all the loads for the wind direction z positive, that means along z direction, we have assigned here. Now we will apply. First we will apply the self weight. In the same way we will apply wz minus, wx plus, and wx minus. I will show wx plus and x minus we will assign. First we will assign self weight, assign to view, assign yes. For all members self weight assigned, it will be considered in the reaction and other loads for the program calculation. Now this is our dead load. We will go to this side view, or we'll go to this side view. I will select, better I want to create new view, property name, by property, from here to here, close, by property, close, go to view, then I want to new view, create. Okay, and first of all we can assign the loads in the interior frame, then we can go for in frame. So here also I will select all of this and I will create new view. Okay, done. So for the dead load I will assign the loads like this, select all, then check it is selected or not, then assign to selected team, assign yes. If you want to see the loading, this the diagram, then I will go to live load, assign yes, then I will go to this windward roof. For this case I will select only one side. Let's start with the windward wall. I will go to view, this side, this along z direction, select all this, then assign yes, you can see this. Okay, now I will select all this, then this one windward roof load, yes. Okay, now I will select this one, then this leeward roof, assign yes, then I will select this one and this leeward wall, assign yes. Now see, this is our loading. Now this is for in frames. All this we will apply this. Now I will go to display whole instruction and I'll go to this. I will select this in frame and this in frame, then create new view. Okay, now for this found dead load here, this one we will add. Go to this view, this control select. Okay, now assign to selected view. Yes, now go to live load, assign. Yes, now for wind load, this is GZ, global Z axis. For this side one, assign. Yes, then for windward roof, we'll select this one, control select, and then assign to selected wing, assign. For leeward load, leeward roof load, select this, then assign to selected wing. Yes, okay. Now for the leeward wall, this one, assign. Yes, now for the side wall load, these two. For positive, these two, positive x-axis, G global X, assign. Yes, and for this two frame, this will be half, assign. Yes, now for these two, load will be negative x direction like this, and for this one it will be like this. So for WZ direction wind, we have got the loads in our model. In the same way, if we want to see the whole structure, we can see this is our load application, and in the same way we will apply the load for WZ minus wind pressure. We have finished our load application for the wind direction in negative along negative Z axis. This is WZ minus, and for WZ plus like this, for WZ minus like this. This is our load application. Now we will go for WX plus. I'll add member load. Okay, for the both roof, the wind parallel to ridge. In this case, both roof will have the same load, 4.4. This is local y-axis, upward, assign. This is not like this. This one I add here, add member load 4.4, add. Now for end frame 2.2, add. Then last both after. Okay, windward wall 4.9, that means along global x-axis 4.9, add. And then for end frame, this 4.9 will be 2.45, add. Then leeward wall 2.8, add. And for end frame 1.4, and the last one sidewall 3.63, we'll add 3.64 along the, in this case sidewall will be this side and this side along z direction. The sidewall 3.64 along global z, add, and for minus z add, for the end frame it will be 1.82 add, and negative 1.82 add. Okay, so now we can apply this wx plus load. First we can go in similar way. We can select the property name, this, close, and we can create new view. Yes, view ready. We have selected also this one also by mistake, no problem. I will select all this and create new view. Okay, now we will go to this side. Here this is for both roof. Select all this, then assign yes. This is for end, and for this gx, this for the end frame, and we'll go for the sidewall. Here these are the sidewall along z direction, this one assign yes, and this one minus 3.64 assign yes. So for positive x direction wind pressure, this is the loads to our frame, and for the we will go to in frame now. Select this one and this one, create new view. Okay, this windward wall, first we will go to this one, windward roof for both side roof. This is 2.2 assigned to selected beam, yes, and this is the windward wall load for this two frame 4.9 yes. For this two frame it will be half yes, and the leeward, for leeward wall 2.8 yes, this for half yes. Now this is for the sidewall pressure, this side. First in along z direction, these two assign yes, and these two side, then like this assign yes. Now we can see the whole structure. So this is our load effect on the frame when wind is going through the positive x-axis. In the similar way we will add the wind load for wx minus wind direction. We have finished our load application for the wind direction in negative x axis, and now this is our load application procedure in Staad Pro for 3D portal frame. In the next tutorial I will create load combination, I will do analysis and design. So till then, stay tuned.
Press the bell icon on the YouTube app and never miss another update.